Hey Cal community, my name is Leyla. I'm a rising senior and a geophysics major in the Earth and Planetary Science department. And this summer, my research is going to focus on the paleomagnetism of the Klamath Mountains in Northern California. So paleomagnetism, it's the study of how minerals in rocks can record information about the magnetic field, sometimes dating all the way back to the time that the rock formed. We're going to be looking at this magnetic information in our samples to understand more about how the terrain that they're from has changed and moved over time. We're particularly interested in the West Coast because this region, known as the Western Cordillera in geologic terms, has a very complex and uncertain history. This cordillera is actually made up of a lot of smaller microterranes, all of which have been attached to the side of the continent over the course of millions and millions of years in a process known as accretion. But there's a lot about this accretionary process that we don't know about. And paleomagnetism is one of the mechanisms that we can use to understand it. Using a magnetometer, we can take our rock and learn about the magnetic orientation that it had when it formed. And we can compare that orientation to its modern magnetic orientation. And using those two values, those two directions, we can see how the rock has moved, how the terrain has deformed, or the plates have, switched around over the course of history, which is pretty neat. Research like this puts together a better picture of the Western Cordillera that previously has been very enigmatic. So it's really, really novel research, which is really, really fun to work on. I actually first got involved in Earth and Planetary Science when I took an introductory course, EPS 50 at Berkeley. It's called The Planet Earth. And that's what led me to my current major in geophysics and my current research position in my lab. Paleomagnetism, I've found, is kind of the perfect combination of geology and physics that led me to my major in the first place. It's been really, really great. It challenges me in both fields. I have to have a really solid foundation in mineralogy, tectonics, and geochronology, as well as electromagnetism and magnetic field behavior. So it's really been a great opportunity to learn about all the different options I have in front of me in my field, and I'm really grateful that I've been given this opportunity from Cal and its many research programs. So thank you, Cal.